All right. So this week we were actually starting talking about um, Siri, right? That's the sound of Siri. Okay, we'll start talking about the actual object-oriented design principles and all those cases regarding how we modify this code from bad design to a well-designed code. Okay. First, let's see a little bit about this slides. What is well-designed software? So before we get into the slides, what do you think is a well-designed software? What's your criteria for a well-designed software? No bugs? No bug, right? Working? Is that enough?
Secure.
Yes, security, yes, secure. It keeps confidential, do not release all the information, it's not easy to hack, and no bugs, and work correctly. Yeah, all those are kind of the criteria there, but anything else?
It encloses all the concepts that we want it to.
Yeah. So there are kinds of like it fits the functionality of why we need that software, right? Yeah. Also, one thing you might forgot is how about after the software is developed. So when you pour out your phone, you have a phone right there, and you check the app store. How many like updates are there? How many updates are pending? A lot. Every day we have a lot of updates, right? Okay, so it's not just like not anymore the time like we develop software then everything is done. After we develop the software, we still need to think about maintenance of the software. So another criteria is how easy it is to maintenance, to do the maintenance to your software, right? Like doing the maintenance, you mean adding functionalities, remove something or change something. So the keywords here is change, right? Change. Okay, so it should be easy to change. Another criteria of well-designed software, easy to change. It does what it's supposed to do. It's easy to change. It meets the standard of object-oriented programming. So object-oriented design is the thing that help us to meet those criteria of a well-designed software. Okay, so it should work correctly. It should be easy to maintain. It should be secure. Are these things? Okay, so we use OO design to help us to generate well-designed software. Okay, let's see. Yeah, this Rick's original guitar store is the example in the textbook. I will show you that in a minute. So let's talk about what is good software. So it must satisfy the customer, must do what the customer wants it to do. Yeah, well designed, well coded, easy to maintain, reuse, and extend it, adapt to changes easily. So 3 steps here. Make sure your software does what customer wants to do. Apply basic OO principles to add flexibility. Strive for maintainable, reusable design. Okay, so basically here is what we what I want to show you in the text box. Okay, let me show you that textbook. So this is basically the first chapter of this book. Okay, obviously I should. So this is Rick, who owns the guitar store. Well, the traditional thing about the traditional guitar store, it did everything based on paper. Based on a piece of paper, you write down what did I buy from the provider and how many guitars did I sell today. Okay, so everything in the on the paper instead of a system. Now Rick decided to design a system for his guitar store, so that it got improved to this age of internet, right? So this is a new application of the store. Just simple, 2 classes. One, the first class, we had the guitar class, and then we have inventory. So what is in the guitar class? We have a whole bunch of attributes like serial number, price, build model type, backwood, topwood, what type of those wood of this guitar. Anyone plays guitar here? Okay, so that kind of wood, the material, it has influence on the guitar, so they want to be attributes there. Yeah. And for the functionality of the guitar, it has okay, get serial number, get the price, basically get everything, get every attributes of the guitar. And another class is the inventory class. Guess what should be included in the inventory class? So if you need a system for the guitar store, what kind of functionalities will you require if you are the owner? Yes?
Inventory? Online sales?
Don't think about online sale yet. So think about the system that manages the whole store, the entire store, search. Exactly. So when we are doing the paper-based system, right? When we want to say, okay, we have a customer. Either you have a good memory, you remember everything in the inventory. So do you have a Fender guitar? Yeah, yes I do, and because I remember that we have that in inventory. Or you can check up quickly on the paper record to see if we have that type of guitar in the inventory in the store. All right, so here when we move to the computer system, wow, search, right? Search functionality. I think that's the very first thing we want for a store, right? So that can increase the efficiency of working of all the business, right? Yeah, so search, and also it has a add and a get guitar functionalities, so that you kind of when you have a new guitar coming in, you use the add guitar function to put it in inventory, right? And when you check the information of the guitar, you kind of use the get functionality from the inventory, right? Okay, so that's a pretty straightforward and simple design. Yes. So here's the code of the design, right? Sample code of the design. Okay, so the guitar, it has a string of all these attributes, and you do know that this is the constructor of that class, right? So every time you create a guitar, you kind of give them the serial number, the price, all this information. And then the get set functionality is just return the price, return the serial number. So there's nothing hard here. And also the inventory.java here. Let's go to this 8, right? 8, so it's easy. We have a guitar, we 8 so guitars.8 guitar. We put the new guitar into the inventory. And the get guitar, we return that guitar with the serial number, okay? So let's see here, the search. This method, search. Let's do not go line by line, but just here we can see we have a for loop. So basically the search algorithm is we go through everything to find if we have that guitar. And how can we do the, well, how can we compare the guitar? So here it does, what it does is it compares the each attributes. See, well, model equals guitar.get model. So if we find all those match, like if we find a match of if there's something that doesn't match, we just skip this guitar. So if everything is match, everything is a match, include the serial number, the price, builder, string, model, those things. If everything match, we return that guitar. We return the information of that guitar. Okay. So probably some of you have questions here, right?
Well, I think as the serial number is unique, so do we need to check all of it?
Yeah.
Just check the serial number.
Yeah. Yeah. Obviously, let's see if it checked the serial number or not. Backward. Yeah, ignore the serial number since that's unique. You're correct. They didn't do that. They actually ignore the serial number. Oh, can you see that? Make it bigger. Yeah, so this is inventory class. 3 functionalities. We're focusing on the search, okay. Okay, ignore serial number. And ignore price. Okay. Alright. So that's, well, seems okay. Right? Is it? Okay, that's fine. Let's continue to see what's the potential problem is. Okay. So then Rick started to losing customers. Let's see what's going on. So this is a class called Find Guitar Tester. Basically, this kind of simulate a user's behavior of trying to find a guitar. Let's say here. So Aaron what Aaron likes. Aaron is a customer who wants to search for a guitar. So he create price doesn't matter, right? So 0 there. Serial number is empty. That's fine. So it's a brand. It's a type of guitar and the wood, top wood, back wood, right? And so that's the thing this is the guitar that Aaron wants to find. Okay, seems okay. All right, but here we start to use the inventory to search for whatever Aaron wants. So if we search something, we print out the information of the guitar. Else, that means if we search, if there's no result for this search, we just say, sorry Aaron, we have nothing for you. So what Aaron got here is, sorry Aaron, we have nothing for you. So can you see the problem here? So this is what Aaron is trying to, well, search, okay? And then let's see this search algorithm, this whole part here. See if we can find some problem.
Upper and lower in other case.
Yeah. That's one of the problem there. So here it's actually the, well, see, Aaron is searching for this Fender, but F is lowercase. However, if we see here, it doesn't say that, right? Is it? Yeah. Okay. Well, here, what they have in the store, what Rick have in the store, is Fender. You see, the F is uppercase. So the first problem here is this program is using string. It's using string to compare everything, right? This Fender, the brand is a name, right? The type is the brand is a string, serial number is a string, type is a string, and the materials are strings. So it uses string for everything. Is it good?
No. It has predefined models, so you will have them as a class if you want. So they will be already listed, and we'll just go through the list. Or the method he used can be broad, so like we're considering lowercase, uppercase, or all this stuff. We'll make it longer.
Yeah. So we all have the feeling that using string here is probably a not good solution, because it creates potential problems. Because at last it becomes a game of comparing the strings. Okay, and and there are a lot of possibilities that string may have, like just directly compare strings like this uppercase, lowercase was one of them, and something like that. So, but there's some way to avoid that, right? So let's try to see what can we do to modify this, to improve this. Okay. What do you write the software? Okay, let's see. Skip this part. It's fine. Okay, let's use this. Yeah, so this is what Aaron wants to match. This is what what's in the Rick's inventory. So a quick fix here, because we observed that this is a problem created by upper lowercase. Quick fix would be we add that functionality to the search, right? So here. Yeah, a quick fix will be try to fix the search functionality so that it meets the first step of creating this good quality, well-designed software. Is make sure your software does what the customer wants it to do. So currently the system is not doing what it's supposed to do. It cannot return the functionality of the search. So here, one way is we do the uppercase comparison. But it may have some other potential problems when using string, right? Because some space, special characters, or misspelling of the maybe Fender, maybe F-E-N-N-D-R. Sometimes the customer do this way, right? So potential problems still exist. So what we do here is, instead of comparing string, we directly compare the type. Okay, compare the type. So how do we do that? Here we have enum type. You know what enum is, right? In the programming language, enum. Okay, so here you kind of get three. You create three enums. One is type. So you have acoustic, electric. One is builder. So you have a different builder. Fender, Martin, Gibson, something like that. And the material, the wood. You have Indian wood, Brazilian rosewood, something like that. Okay. So all of them are created as enum. Enumeration, enum. Okay. So you just list all the types of type, builder, and wood. Okay, so we create those three enum classes to help us to compare the this enum, and we have a toString function. Okay, to just kind of convert this enum to string. This enum in the system, it should be represented. If you want a value, it could be some integer value here, but it is created enum, so it's a type dot acoustic, type dot electric. That means the type can only have two kinds of value, acoustic and electric. But if you add more, it can. If you modify the class, it can add more. The builder can only have Fender, Martin, all those things. And the wood could be all this type of wood. Okay, so we use the enum. Okay, but how will the enum change this thing? Okay, so with the enum, it kind of helps us with the question. So this is what Aaron likes. When we create the guitar class, we no longer need the string. Right here, see, we do not need the quotes Fender. Here we use builder.fender, and we use type.electric. Okay, we use wood dot some type of wood. Okay, all right, we use this type to directly create the guitar we want to search. And also another change in the search here to here. Okay, yeah, so we compare that through we're still doing the comparison of the string, but this time it's better because all the string they are created from this type. Okay, so there's only one way to convert Fender to string. Just the Fender, it will convert to the same string because they are created with the same brand. And they have the same toString method. So this comparison will create less problem than the very first design. Okay, so we just use the type instead of this just comparing the string. Okay, but okay, it actually works pretty good. It does what the customer wants it to do, because every time you search, when you search, it returns something, right? Let's see. So make sure the software does what the customer wants it to do. So we have a builder type and a wood, and we have the guitar and inventory. So this is how the system looks right now. We have 3 more classes, enum classes. All right. So seems good. No bugs. Works correctly. But can we further improve it? Or do you have any other suggestions to improve it?
Maybe show something similar.
Similar?
Can't find the exact one.
Yeah, similar, yes. Yeah. So yeah, when you're trying to search for a guitar, right? Right now the search function, see here. Where's the search function? Yeah. Yeah. Well, the search function here. What's the return type of the search function? It's a guitar, and it's a guitar, right? When you're trying to search, you just think about Amazon. You search for something. Does it return a product? No, it returns a list, right? It returns a list. So that's create a potential, not potential problem. It's just we can do better here, right? So we wanted to return maybe a list of guitars. Because if we just search for Fender of every guitar with the brand of Fender, we want to see how it looks like, and we want to make further decision. Okay, and when I come into the store, I may not know what exactly I want, right? Yeah. So let's continue. Yep. So the customers want the choices, because we can have two guitar and only different names, serial numbers, but different prices, but the other things they're similar. Yeah. So the customer kind of want to compare them. Yeah. So we want a list here. If we want a list here, okay. Well, we have to kind of search. We kind of modify the search function, right? So here is the okay. Here is the new search function, and here is the some of the words that you might grab and fill into the blanks. Okay, trying to. Well, the purpose here is to make the search function return a list instead of only one guitar. Okay, so let's take 5 minutes quick exercise to see how can we finish this new search function. Okay, I'll give you 5 minutes. Maybe take out a piece of a paper. Do this. Can you read this here? Oh, yeah, those are the candidates of the answer. You just grab them into this, put them into the blank, throw them into the blank. so hard. Okay, let's have one more minute. Okay, let's see what the answer is. So obviously here we need put a list, and we need some certain type of list. Here is we add the result to that list. Here is what we return that list. So here is a public list search for a guitar. Okay, so we created a new list with this linked list. Yeah, and well, here the choice we have linked list and the array list. They are implementation of lists, so both of them is okay. All right. And then what we do is we go into that for loop. We're going through to find everything. Say if we have those match, we find a match, we put that match into that list, right? Then and then we go through the loop again to find all the matches inside the inventory. Then we return that matching guitars. This is the list. Yes. Okay. So by doing this, we kind of fix a problem of further improve that. Yeah.
One question.
Yeah.
Instead of using linked list or array list, do we have just use list when creating the matching guitars?
Yeah, that depends on well, maybe the programming language you're using. Okay, or if you have usually I think you have to, well, list is abstract. It's abstract class, so it doesn't have a, well, usually it's abstract class doesn't have a its own like implementation, so it's maybe can be an interface, right? So we need an actual list is actually a parent class of linked list or the array list. Okay, so unless it has the programming language you're using has the implementation of list, then you can use that. Okay, or you have your own implementation just called list, then you can use it. Yes. Yeah, so this is the test drive. Yeah, so well, with that being built, we have guitar, we search for Fender and electric Elder, yeah, and then kind of here we're trying to search for that guitar, and the output we change a little bit because we want to output everything there. So this is going good. Yes, this is exactly what I wanted to do. That's what Rick says. So it returns two guitar. One is with the same searching criteria. One is 1500. One is 1,550 $. No. 15. Sorry. 1,550.
Crazy expensive for guitar.
Yeah. Okay. So that's it's expensive for guitar, but well, sometimes those instruments they can be very expensive or just $100. So the app does what Rick wants. We are finished up this step. I make sure what software wants us to do. Okay. All right. Do you see any other potential problem here? So this is basically the logic here. The client provides a set of specifications, and the search method is called with the specifications to the client, and it begins a search on Rick's inventory, and each guitar Rick's inventory compared and return that list. Okay. Yeah. So it actually functionality wise it's good because it does what the customer wanted it to do. Oh, can we have some further improvement? Like think about the principles of object-oriented design. Think about encapsulation. Okay, now it's not the problem of functionality. Okay, think about object-oriented design. Think about well, the encapsulation, something like that. Think about why do we want to have a class objects? Right now we are well, basically we're searching for guitar with guitar, right? We're searching for this guitar with a guitar. But actually what we did in real life is we search for the guitar with the information of the guitar. Right now what we're doing is we create a new object called guitar, right, from my specification, right, in the test drive. Remember that? Here, guitar, what Aaron likes, new guitar. Does it make sense here in this part? It brings no problem to functionality, yes. But is it really necessary? Or do we want to search for a guitar with a guitar with the actual guitar? Like this is like kind of like I bring a guitar to the store and you just search for the guitar to see if there's any guitar match my guitar here. But actually what actually doesn't, it is not working that way, because when I want to search for guitar, I didn't bring a guitar. What I do is I give the information of that guitar, so you search for the guitar, right? So we might not want to create a whole class called guitar here. Okay, let's see. Let's say some other possible improvement here. So here, some principle here. Objects should do what their name indicate. Okay, so obviously there is some type of violation here in that guitar class, because guitar is supposed to hold a guitar, but what Aaron didn't bring a guitar. He just bring the information of guitar. So we shouldn't create a new guitar class with the information, because there's no actual guitar. But here the principle here, objects should do what their name indicate, and each object should represent a single concept. Unused properties are a dead giveaway. So here we might probably want a new class called guitar specification, right? Because what Aaron brings is a specification of a guitar. You agree?
Yeah.
It's not bring a guitar into the store, it's bring the information. So if we follow the principle there, we want the class state what the class name indicate, what it's supposed to do. Okay, so let's try use the guitar specification. All right. Well, just we can make the guitar specification a part of guitar, because the guitar has a specification. That makes sense, right? Guitar has its information. Guitar has a specification. Like you has a name. You have a name, right? Something like that. So okay, let's try to move the thing from guitar to guitar specification. Yeah. Yes, builder, like builder something type model would. Okay, how about the functionalities here? Okay, so whatever you moved from the attributes, you have those gets functionality there. Yes, so that's we kind of separate the information out, because we're using the information as an individual class, because what the customer brings into the store is the specification, not the actual guitar. So we need a specification class. Yeah, so build model would tie backwood, topwood. So what left in the guitar is the serial number, price, and a new member specification. Okay, and here we move all this functionalities to the specification, and it gets space, and the gets specification, it returns the guitar specification type. Okay, so we use the aggregation here, put the guitar specification a part of this guitar. Do you think that's necessary? It seems just creates our work of coding this thing up, right? But can you think of any potential benefits of doing so?
It's easy to maintain, like when we want to raise the price of a guitar.
If you only think about functionality, you won't find benefits here. But if you think about the future, think about maintenance, there could be some potential benefits. Okay, let's see. Now you update your code. We're in the second step, apply basic. So the first step we just done, make sure the functionality okay. Then we apply basic OO principles there to aid flexibility. Okay, so one of the important principles here we apply is we want to make sure that the class has their own responsibility, and it does what makes sense for that class to do. So when we update the code, well, the search, we're no longer using the guitar to search for guitars. We're using a guitar specification Yeah, we use the guitar specification. Guitar, select guitar. Let me see. To search for the guitars, yes. We use this guitar specification to search for the guitars. So we get information from the search specification dot get builder, search specification dot get type to make that comparison. Okay. So that's how we update. And this is a test drive because it's gonna work because what we change is not functionality, it's only the structure. So it brings this kind of thing that well, why it matters here. So what OO brings is the flexibility, encapsulation, functionality, and the design pattern. So flexibility is like well, it brings that flexibility that delivers the functionalities. Encapsulations about reuse, making sure that you're not trying to solve a problem that someone else has already figured out. And functionality is the thing that your code stay the same, separate form from the parts that change. Then it's really easy to make changes to your code. Yeah. So when you follow the principle, it will make you easier to change the code. And design pattern is well, a design pattern is something that has been, some of the structure or pattern has been applied again and again. So it saves some time for your design, then it ensures the quality and maybe security of that thing using the same design pattern. Okay. So let's see, after the change, this is what's happened. As functionality wise, same thing. But let's see what's the difference. Okay. We applied the OO principles to aid flexibility. Seems like I talk about this benefits here, but seems like we didn't see that from our current code or current usage of the code, right? So let's continue read. Now here, this is the search method from the inventory.java. Okay, let's take a close look here. Take a close look at here. Can we do some other changes to further improve it? Well, so far we have all the functionalities correctly, and we applied these OO principles. So we separate by separating the specification from the guitar. Okay, and now, okay, I'm gonna do another change here to improve this system. Looking at this, look at the search function now. Look at the search method. What can we do with it? No clue, no clue. That's fine, because we are new to OO, right? Okay, it's fine. Let's see. So it starts from here. Well, the guitar the guitar. Well, in the future we may have some change the guitar. Like here, he plays 12 string guitars. How hard would it be to update the guitar so that he can sell 12 string guitars and let the clients search for them too? Right now the application do not support a new type. Let's see the current guitar. Guitar has a series number and the price and guitar specification, right? And let's see, guitar specification has a builder, model, type, backwood. There's nothing here specifies how many strings are there, right? Okay, there's no place to do that. Alright, so let's see, if we want to update the thing to have a 12, to adapt a 12 string, what do we do? So what we do is we add a property to guitar specification, but we have to change the code in the inventory class search method as well as in the constructor on the guitar class. Yeah. So that what needs to be changed is here we want to some type of a specification of how many strings are there, and search method, because we also want to take into consideration of this number of string, this type of attributes, right? Okay, so you see there's some potential problem here, because when we are trying to update this system with a new type or maybe new instrument in the future, right? First, we need to update the guitar specification. That makes sense. But we also need to update the search method. Yeah. If it's a more complex system, you may need to update a lot of classes. So this implies some improvement that you can make. Because when you are trying to do a change, when you are expecting this change in the future, you kind of need to design for this change. Okay, so if it requires you to touch many classes to adapt to one change, first it's gonna be, well, be more vulnerable, because if you change more things, more errors, more bugs could happen, right? And it doesn't quite to fit into this OO principles. Yeah. So right now we need to do that. We need to change here and change there, and we need to touch three places. One is guitar specification, one is a constructor of guitar needs to additional property, and the inventory, the search method of inventory, right? So a lot of place to update. If you forget one of them, there will be error in the system, right? Yeah, doesn't affect the code. Yeah. So your task here, try to add a number string property and get number of string method to guitar specification, and modify the Java, change the search, update the test.java. Yeah. So we know how to do that, so we're not doing it here. So what we want to do here is to change the solution. This is what we do, yes. Okay. Yep. The application should be refactored so that adding properties to Git specification doesn't affect the code in the rest of the application. Okay, so anyway we can do that. That's basically last part. So that involves concept of delegate. Okay, let's see here. Guitar specification here, that's fine. We have new properties, number of strings, right? And we just need to update the guitar specification, builder, and number of strings, and get strings, return the number of strings, yes. But here, what's even better is we want, this is a public guitar, this is a constructor of the guitar class, right? So the original one is we create the guitar with serial number, price, model, type, material, the wood, right? Those specifications. So here we just need the guitar specification. We change that to only need guitar specification to create the guitar. So that when guitar specification actually change, we don't need to touch the guitar class, right? Because we can just limit the change to the guitar specification, right? And the search method. If we have a guitar in the guitar specification, we have our own method of match. Okay. Then we don't need to actually implement the search method like comparing everything. We can just use guitar specification dot matches and to test if the two specifications they match. Okay, and we can put that thing into the, we can put that match method into the guitar specification class. Okay, so that everything there encapsulated into one class, right? That's why we have this. That's a good thing about we have this guitar specification class. In the second step, it seems we just want to meet the principle of the class does what the class name implies. And here is actually the benefit comes because we can put this thing, this matches, delegate this method to the guitar specification class because it makes sense for the specification class to make the comparison with other specification class. And it makes sense here since all this model, this type, they are attributes of the specification. So here we just use specification to construct the guitar instead of every single attribute. Okay, so that if we have this two design here, right? One more thing we need to do is we move part of the code of the comparison from the original search to this match functionality. Okay, then this we can do the match within that guitar specification class, right? Okay, so that every change has been restricted, encapsulated into that single class, so that Okay, now it's adding a 12 string. Well, in the future, if you want to add a 100 string, or you want to add some guitar that's maybe acoustic guitar, electric guitar, maybe some other attributes may change, right? Like a condition used, you have a new attribute. The condition of the guitar, pre-owned, brand new, or something broken. Okay, so if you want add in that attributes, what you need to do is there's only one class you need to touch. Which is it? What is it? Yeah, guitar specification. You no longer need to touch the guitar class and the inventory class. Okay, that makes sense, right? Because the inventory class is like the core of the system. If every time I add the attributes, I have to touch the core of the system, that become pretty vulnerable. This system expose you to a big risk of crashing the system, right? So by having this guitar specification class, we restrict the other changes into that class. Okay, so that it's easier that we can adapt to changes, future updates, future improvement, change of requirements in the future. So maintenance, we reach the maintainability here. Yeah. So this is the test drive. It's still the same, return the same thing. However, the internal structure is totally different. It's gonna be especially when the system size is growing, it's gonna become a disaster if it's not well designed. It's gonna be a disaster if you want add some single attributes. But if it's well designed, like here, when you add in the string numbers, condition of the guitar, you can just change this guitar specification class without touching anything else, and everything will work. Yeah, so that's a benefit. So that's why we call a well-designed software, right? Okay, let's go back here. That's why we call it well-designed, right? A good software. Satisfy customer. What did you do? And easy to maintain, reuse, and extend. That's the important criteria. That's what we want to use OO to help us to reach this criteria. Okay. All right. So that's it for today's class, and yeah, I'm gonna actually there are 2 lectures, so I will post both of them online, and it's gonna be slightly different from what I talked about. So today I kind of condensed things into one lecture, but I will also post this 2 lecture in the D2L system. You can find the time to go through the lectures, and also there are also other important things like responsibility-driven design. Let me briefly go through that. Well, just maybe 2 minutes. So this we kind of we have this already, but the important thing here is I want to show you the CRC card. So it follows what we want to do with a class, 'cause we have a class name, right? Well, whenever you design a class, you kind of using this CRC cards to indicate how many classes in the system. So we have class name. We have indicate how many subclasses do we have. Well, it's optional, but the superclass is required because you want to know that what your parent is. You may not be aware. You may not be aware of who's your children. Yeah, that's fine for this class. That's fine, but you need to be aware of who is your parents, who is above you. Okay. Here, the core here is responsibility and collaborators. So responsibility, describe what is the responsibility of this class that's fitting our principle, because we want a class to do what its name, what it is supposed to do. We don't want well, you can. We don't want a student class to have the functionality of teaching, of giving courses. So that's, well, maybe you use the teaching functionalities should be it should be the responsibility of the professor class, right? So we need to clearly identify the responsibility of the class and the collaborators. Like when I was teaching, I'm collaborating with you so that we can doing this. I'm collaborating with the IT person so that the devices in the classroom is working correctly. So that's the purpose of why we need a CRC card, to remind us that when we design every class, they should have a clear responsibility for that class. A car is a car. It's not a boat. It's not an airplane. Okay, it should not fly. Something like that. Yeah. So that's why we need this CRC card in this responsibility-driven design. Responsibility-driven. All the classes are created from their responsibility. Okay. All right. All right. So that's basically about today's class. All right. Thank you very much for your time today.